Welcome back to the Mechanics of Solids lecture series. We're solving for shear and bending moment diagrams graphically using a set of simple rules. The next example that we'll look at is the simply supported beam with an overhang and various types of loads as shown. In this video, we'll solve for the reactions. If you already feel confident about solving for reactions, please feel free to skip to the next video. At my pin support A, I know I'm going to have a vertical reaction, which I'll label A sub y. And at my roller support at B, I'm going to have a vertical reaction, which I'll label B sub y. To save some time, I'll use this as my free body diagram. First, I'll solve directly for B sub y by summing moments about A. The sum of the moments about A equal to 0, taking positive in the counterclockwise direction. I have the contribution due to B sub y times the distance 8 meters, and that acts in the counterclockwise direction about A. Then I have the concentrated moment, 80 kilonewton meters, which also acts in the counterclockwise direction. And notice, because it's a concentrated moment, I don't have to multiply it by any length. I just add it in, and it doesn't matter where it's located. Then I have the contribution due to my distributed load, spanning between A and B, and that's a negative moment. So minus 4 kilonewtons per meter times the length, which is 8 meters. And then I'm going to multiply it by the length over 2 to get the moment arm, so I can square this and divide the whole thing by 2. This is my shortcut rule, WL squared over 2. And then finally I have the contribution due to this concentrated force at the end, minus 30 kilonewtons, because it's in the clockwise direction, times the distance over which it acts, 12 meters, and set that equal to 0. So solving for B sub y equals, I'm going to negate all these signs, negative 80 plus 128, which is the result of this calculation, plus 360, which is the result of this calculation over here, and that's kilonewton meters, tracking my units, divided by 8 meters, so the meters cancel out, and I get B sub y equals 51 kilonewtons. Now to solve for A sub y, I'll take sum of the forces in y equal to 0, positive acting upward. I have A sub y plus B sub y minus 4 times 8 kilonewtons due to the distributed load, and minus 30 kilonewtons due to the concentrated force. Set that equal to 0. We get A sub y equals negative B sub y. Substitute the value of negative 51 plus 32 from this term plus 30, all are kilonewtons, and this reduces to 11 kilonewtons. So my answers are B sub y equals 51 kilonewtons and A sub y equals 11 kilonewtons.